You're watching TelecomTV's exclusive video coverage of the Gen 15 event from Dallas. I'm joined now by Bob Metcalfe, who is Professor of Innovation at the University of Texas in Austin. He's also the founder of 3Com and of course the inventor of the Ethernet. Bob, thank you very much for joining us on TelecomTV.
Thank you for having me.
It's been about 10 years or so since we last spoke, and the industry has changed tremendously since then. In your keynote here at Gen 15, a question was raised about will future generations see this year, 2015, as a turning point for the industry?
Well, the turning point question is funny because it keeps coming up. You know, when you have an exponential, sort of each year can be a turning point. So will this be a turning point? We may have a bursting of the internet, another bursting of a financial bubble this year. That would be a negative turning point. On the other hand, we have the accelerating adoption of carrier Ethernet for growing what I like to call the Gigabit Ethernet. You know, we had the kilobit internet in the 60s and 70s, then we went to the megabit. Now maybe this is the turning point year to get to the Gigabit Ethernet as we get there slowly. The Internet of Things is beginning to take shape. You know, that's a buzzword a super buzzword, but we're beginning to learn what the things are going to be, and that's interesting. You know, automobiles, personal health monitoring, smart cities, and so on. So maybe this is the year the killer apps emerge. That would be a turning point. The killer apps of the IoT, then that would make it a turning point year. And we're finally making, you know, standards progress. MEF is making progress with the service offerings of Gigabit Ethernet service offerings, LSO. SDN, NFV, you know, all those buzzwords are starting to be put in place. So the argument could be made this is going to be a turning point year, yes.
How far do you think we can take the development of Ethernet? Because it seems it really is becoming fundamental and a foundation to build on with SDN and NFV. It just seems that it's a critical component.
Well, there's a bit of a word game going on there. So Ethernet the word was coined in 1973. And it meant a very specific thing then, and that word has been evolving. So what we do now is whenever something new and important arrives, we call it Ethernet. So apparently, if we keep doing that, Ethernet's going to be around for quite a long time. So it's just to be clear, the Ethernet we built in '73 bears little relationship to what we're all using today. So the arrival of SDN and NFV they look to me like the next logical step. I mean, we virtualized storage a long time ago. We virtualized processor. It's time to virtualize the network. It's often the case that there are trends from hardware to software. So with SDN and NFV, we're moving a little bit away from what some people call proprietary hardware to what some people call non-proprietary hardware by moving to software. It's time for all that to be happening. And if you want to call that Ethernet, I'd be delighted.
As Professor of Innovation, what developments are we seeing within the network and on the network? I mean, who's driving this? Is it the telcos who are pushing innovation, or is it the fact that we are moving more into an open source world, that we're embracing a wider ecosystem of developers?
That's a great question. I think, as I just finished saying in my opening remarks here, the Ethernet model, that's what I think Ethernet is now. It's a model of innovation. And one of its principles is build it and they will come. So the Ethernet part of the carrier world, or the internet part of the carrier world, is pushing faster and better networks even when the requirement isn't clear. Sort of build it and they will come. And that's going on, and that's really, they haven't stopped doing that. Gigabit access is being offered in Austin, Texas by no fewer than 3 or 4 companies. I mean, Google Fiber set it all off, but now they're all offering gigabit. And there's no requirement for gigabit. My internet service is just fine at 20 megabits per second or 30 megabits per second, but we're going to go to gigabit, and that's going to turn on a whole bunch of new applications. The National Science Foundation has taken an interest in what will the new applications be that you can do on a gigabit internet that you can't do on a megabit internet. The US Ignite, it's called. That's a National Science Foundation project. And so what's emerging is a lot more collaboration using a much higher speed network. In Austin, Texas, one of our problems is traffic. And what are the solutions to traffic? Build more roads, put in mass transit. There's a third one now, Gigabit Ethernet as an alternative to traffic. Why move all those atoms around when you can move the bits instead? So there's the build it and they will come ethic is pushing from below, providing more and more capability. And then it's just natural for these new killer apps to emerge that weren't previously possible.
So as well as provisioning these gigabit Ethernets, and in some cities in the US, we're seeing 10 gigabit services coming online. Yep. At the same time, as you mentioned, we've got the Internet of Things emerging. So we've got billions of potential devices connected to the network, most of which are using very low bandwidth. So I think it's an interesting mix between the high bandwidth requirements we might be looking at, but at the same time also the low ones. I'm just wondering, how important are the carriers going to be to the Internet of Things and supporting the Internet of Things, and what kind of innovation we're going to see there?
So very high speeds are driven by two things. One are the high speed apps, like video collaboration. I heard recently the day that Facebook turned on automatic video play, traffic on the internet went up 7% that day. I don't know what the fact is, but it's like that. Phenomenal alteration to a single app. The traffic goes up. In the case of the Internet of Things, as you point out, all the devices are likely to, as far as we know, are likely to be very low bandwidth, but there are going to be gazillions of them, so that also aggregates up to very high speed. So we really need 10 gig, 100 gig, 400 gig, terabit plumbing in the middle of the network for those two reasons: the increasing bandwidth of new applications, but also the proliferation of gazillions, whatever the number is, 50 billion connected things, whatever they are, things. Why do we call them things? Because we have no idea what they are.
Good point. We don't know what they are. We're just hoping they'll be used.
But this year we're beginning to figure out what the things are, I think. So that may be the turning point. This is a thing right here I'm wearing on my wrist. It's connected by Bluetooth to the cell phone here, which is connected by either Wi-Fi or LTE into the internet. And this is the thing, and this is a valuable thing. I'm giving it a chance. This is an Apple Watch, and it's not the killer thing yet, but I'm giving it a chance, and it's beginning to indicate to me that so personal health monitoring is an emergent app for the Internet of Things, I think.
But in either case, we are definitely moving to more virtualized architectures, more software-defined architectures, and more open architectures.
Which is all good.
But when we say open, what exactly do we mean by open?
There's flavors of open. There's open source, which means you take all your effort and share it with the world for nothing. I'm exaggerating. And then there's open as in the Microsoft sense, which is we have Windows and it's open. You can write, anybody can write. There was a time when operating systems were not open. Back before Microsoft, the OS and the apps were all sold by IBM. And so it was a big step forward to open up. Apple did this, Microsoft did this, Sun did this, to open up the programming interface for apps, and that allowed this spaghetti against the wall phenomenon to occur. Lots of people threw spaghetti against those APIs, and so we got all those cool PC apps. So there's open meaning the whole thing is open, and then there's open meaning there's an API facing up, which produces a lot of serendipity. Ethernet has typically been open in the second sense. It's not been Ethernet. The implementations of Ethernet have typically not been open source. Certainly not at 3Com. We invested a lot of money and intelligence in trying to design our apps, and then we sold them in fierce competition, but we didn't give them away. We fiercely got as much money for them as we could given the competitive environment. And that, by the way, drove the fierce competition drove the cost of Ethernet to zero. From the first Ethernet card I sold for $5,000. And then it took, it's been 30 years. It's $5,000 to zero, and that's not because of open source, but because of fierce competition in an open standards environment.
Well, fascinating as ever. Thank you very much indeed.
Thank you.